Buffer calculation 2. pH equals pKa plus log base 10 base ratio of base to acid. This is the conjugate base and that's the weak acid. This is Henderson-hasselbalch equation, and here's the question. Calculate the pH of a buffer solution containing strong base of 0.1 mole per decimeter cube sodium ethanoate and 0.25 mole per decimeter cube ethanoic acid with pKa of 4.76. So we need to calculate the pH. We've got the weak acid, ethanoic acid. The concentration of the weak acid is 0.25 mole per decimeter cube. We have strong base because of the sodium. So that's sodium ethanoate. That makes a strong base. That means the solution will dissociate completely. This will dissociate partially because it's a weak acid. And that's a strong base. That will dissociate completely in solution. The concentration is 0.1 mole per decimeter cube. This is the weak acid dissociating partially in the solution. So we have large quantity of this because it didn't dissociate. We only have small quantity of this. This is the strong base. So the strong base will dissociate completely. That means no more of this. So we got zero value of this, and we got large quantity of that and large quantity of this. So we now have in the buffer solution large quantity of the weak acid and large quantity of the conjugate base, which is the base in the solution. We're also given the pKa, and that is 4.76. This is the buffer solution now, the weak acid and the conjugate base of the weak acid. We write down the Henderson-hasselbalch equation, and we now need to find the pH. So now we plug in the value for the base and the acid and the pKa, and this is log to base 10. And therefore the pH will be equal to 4.76 minus 0.39794. The pH of the solution for buffer equals 4.36. This is not the maximum buffering capacity because the ratio of the base to acid is not equal to 1. If the ratio equals to 1, we get a maximum buffering capacity, and the pH will be equal to pKa. That is the maximum buffering capacity. So the maximum buffering capacity will be when the ratio of the base to acid equals to 1, log base 10, 1 will be equal to 0, which means the pH equals the pKa, and that's the maximum buffering capacity. That's the best buffer solution.